Welcome to the DCG revision series, Section A higher level short questions, and we're focusing on the year 2020, and the 4 questions you can see on the paper. We are now going to investigate them and discuss them in the context of the exam. Welcome to the Leaving Certificate DCG revision series. Okay, so I'm going to start off this revision series with Section A. Okay, so we're looking at the higher level Section A from the 2020 exam paper. So, just from a format point of view, for this year's exam, in your Section A, you'll have 4 questions and you'll have to answer 3. So that's as per standard in the previous years. So there's no change there to the format for Section A. Last year, what we had, question A1, we had an axonometric. A2 here, we had a kind of we call it maybe a planes type projection question. A3 was a conics parabola question, and question 4 was a skew lines question. So as per the exam paper last year, candidates who sat this paper last November, there were people who chose not to go with calculated grades. They wanted to sit the exam. The 4 questions and answer 3. This year it'll be the same for you. 4 questions, answer 3 in Section A. So we're going to start off here with the first question, which is the axonometric question. So the image below shows a paperweight. It consists of a cube and a square prism, which intersect each other. The drawing shows an incomplete diametric projection of the paperweight. A pictorial view is also shown. A. Complete the diametric projection of the paperweight, and B. Determine and indicate in degrees the true angle between the surface AB, CD and the horizontal plane. So, the information we're given at the moment, we have an image of the object, we have a 3D graphic, and then we have the setup. So there's quite a lot of information there. And with this question, what we want to establish, okay, is that it's a diametric, okay? So, for example, if you were thinking that these points, when we project them back in, are going to be 30 degrees like your standard isometric, that would be incorrect. We follow the same angle as the projection lines that are on the exam paper. Okay, so we're going to need our sliding set squares. Before we do that, I'm going to do a little bit of preparation work, just to help me visualize, and I'll always look at the 3D object here. So, for example, the cube is labelled with letters, and that's fantastic, but the base is not labelled. So I'm going to call this 1, I'm going to call that 2, okay? We'll call this 3 and 4, and we'll call this 5 and 6. Now, in terms of the back of the cube, we don't necessarily have to show the hidden detail there. We just want to show the front face, okay, of what we can actually see. So we're going to start off there. Now we're going to apply our labels like so. So we're going to call this 3 and 4 in the elevation view, or the end view. In this case, 1 and 2, and behind them we'll have 5 and 6, like so. And in this view, the way we'll see it, it'll be 1 in front of 3, and it will be 2 in front of 4, and it will be then at the back, then we're just dealing with the 2, 5 and 6. Okay, so I'm going to start off with that base, and then I'll focus on the cube after. So, sliding set squares here now, okay. You remember, in the exam, that page has to be taped down. When you are squaring it up in the exam, square it up. The line of the T-square, I generally line it up with the line at the bottom of the outline boxes for the questions, okay. Or if you want to pick an XY line, generally they're all printed off to exact, alright? But don't necessarily go from the edge of the paper. Pick one of the lines on the paper that's horizontal and then tape your page on. Time-wise, you're looking at, for these questions, you're going to be looking at about 10-15 minutes maximum per each question, okay? So, let's project now. So I'm going to take my points here. I'm going to line up my sliding set square like so, okay. I'm going to extend on the line there for the first set of points. 2 and 4 are going to be on that. And don't worry about the lengths of the lines, okay. Draw them on. I'm using a marker here because I want you to be able to see clearly what's going on. And like so. Then coming in from the opposite view, we'll have 2 and 6. Again, we'll line up our set square there. Extend it on. Extend it on. Just draw them in lightly. Extend it on. And extend it on. And we can locate everything now in a moment. So, what we have here now is I want to find 3 and 3. So there's point 3. There's the line for 3. There's 3. So that's 3. Then we have 4 and 4. There's 4. And then we have the points 1 and 5 on this line. So we'll go, that's 1 there. That's 5 back here. And then we have 2 and 6. So we'll have 2 there. And we'll have 6 back here. Okay? So that's the base points, very quickly located. And I'm going to kind of fly through this because I want to kind of, you know, move on with the questions. And then I can heavy what I need to heavy at the front. Now, as I do that, just be as neat as you can, alright? Okay? Don't be messy. I know you might be conscious of time and so on. The other lines going back, alright, for example, into the back corner, you can see the projection lines will carry those lines back, but I'm not going to heavy them just yet, not until I complete the cube. Okay? So now we're going to focus on points. So for example there, I'm going to take point C is found, D is found, B is found, and A is found. So I have E, F, and G at the back. So I'm going to line up there, make sure I'm good on my line. So I'm going to bring F back. Okay. I'm going to bring E back as well. So key thing here, sliding set squares, guys, and also point G there. G intersecting the surface, and I'll have point H as well intersecting the surface too. So I'll bring that as well. And H. Okay. Now from the opposite direction. Okay, we're going to bring the other points back. So let's say we focus on just lining up first with our sliding set square, make sure we're at the correct angle. I'm going to go to point H, or G first. That's the one that's kind of appearing for me first. So I'll project from G on to hit the projection line for G, which is right there. I'll mark that immediately to avoid any confusion. There's G. And then I have H. We'll take H. Project H on to meet H. And then we'll have point F. So we'll take F to meet F. So here's the line coming from F. Here's F here. I want to bring it on like so. So there's F. And then we have E up here at the back, the hidden detail. So now we'll bring E. And E meets E right here. Okay, so now what we want to do, we know that A joins E, alright, and it will be visible in the case of this particular part of the question. So we'll go right there. We know that E joins F, and we'll be able to see that too. And we know that, apologies there now, I'm after getting a little bit of a smudge off my marker there. And we know that F joins to G, like so. And we know that F joins to B. So it's a matter of just joining up the correct points here, really. And apologies there about that marker smudging there in the corner. We know that C joins to H. And we know that across the bottom then, that H line, where we have the intersection on the surface, G and H will just simply join with a line. Like so. So what I'll do there is I'll just add a little bit of colour just to tidy that up so we can see what the surfaces are and that we know what we're doing. So I'll make that a yellow surface there. That's that surface there. Now obviously in the exam you don't have to colour in. That yellow surface will be lightly in behind there. I'll do another surface there. There's the bottom. Okay. So we'll just give it a little bit of a shade there so we can just see it. And of course in the exam you don't have to be doing this, but for visual purposes, for revision, no harm for it. I need to show you a few bits and pieces there. Okay. Like so. Okay. And then the base then we'll give it a greeny colour. like so. Keep it simple. Now, as I said, I wouldn't be factoring in colouring in into the exam really. Just get it done. Alright, I'm just doing this so you can see the bits and pieces, make it a little clearer for you. Now, what I want to do there in that view is I want to heavy back. See my projection line from 3. I want to heavy it back till it intersects the line here, and likewise the line going back here. So to complete out that surface, and of course I'll just apply a little bit of green to that as well, just so we can see there. Okay. Now, so that's fine. The other surfaces then, I'm not too worried about how they're going to look. What we can do there is we can just colour the rest of them in, shade them in a little bit there. Okay, like so. Now, so there was another part to that question. That's the first part. Part B, determine and indicate in degrees the true angle between the surface ABCD and the horizontal plane. Now, look, normally speaking, there's a very obvious solution in these cases. What we need to understand is that we need really an edge view of that surface ABCD, and thankfully in the question we actually have that edge view. So what we're going to do now is we're going to identify that the edge view for ABCD is actually in the end view position here. So what we do is we extend out the bottom line of our object, because we can assume that's going to be like horizontal plane. Okay, so we can call that HP. Just extend the line out. So imagine a triangle, the bottom line of the triangle, extend it on out. That's the ground. And what we're going to do is we're going to line up with the line ABCD, and we're going to extend that line on. Okay, and what that gives us is it gives us an angle. Okay, that gives us an angle, and that is equals, if I take my protractor, indicate in degrees, make sure you measure it and write down the answer. Okay, we are looking at something in around 55 degrees. Okay, so 55 degrees, that is the angle. Okay, so that's the first bit done. Alright, now we'll move it on down to the next question. Okay, so A2. The image below shows a drawing board and 2 set squares. The drawing on the right shows the plan and the incomplete elevation of a similar drawing board with a 30 degree, 60 degree set square and also a 45 degree set square. A, complete the elevation of the drawing board and the 2 set squares, and B, a line from point A is drawn on the surface of the board. The line has a true length of 50 millimeters and makes a true angle of 45 degrees with the bottom edge of the board. Draw the projections of this line. So, straight away what we want to do, focus on part A. We want to complete out the information up there in the elevation. Alright, so we know, for example, right, we can label points here. You want to take the time to label, great. Okay, if you don't, I don't really care. Okay, but I'm going to label 1, 2, 3. Okay, and then we can call the inside ones 4, 5, and 6. Okay, like so. And then we can call these ones over here 7, 8, and then we can go inside here and we can go 9, 10, and 11. Okay, now once I have that, okay, what I want to do is I want to establish up here in the elevation what I actually have. So I have point 2, I have point 3, and I have points 4 and 6. And then I also have point 1. So what I need to find is I need to find point 5 and I need to find point 2. So in order to do so, well, I can see that 3 joins to 2. So straight away in the elevation I'm going to line up 3 and 2. And I'm going to join them. Okay, like so. And then I want to find point 5. Now there's a couple of ways. I could probably go parallel and so on, because they are going to be parallel. So if you wanted, you could use your sliding set squares. I'm going to show you a little trick here. Okay, so take a different colour. What I'm going to do, I'm going to do a little trace line projection around. So I'm going to go parallel to the edge here. Okay, sliding set squares, slide it down to 0.5. Okay, so you're bringing 0.5 over to the edge. Okay, then you're going to bring 0.5 from that position up to hit the edge in the elevation. Right, so right there. So we'll put another little directional arrow on that, and we'll bring the line in. And then what we're going to do is we're going to bring 0.5 straight up to meet that line. Okay, so, and we'll just put directional arrows there, and there's 0.5 located. Now, you could, as I say, go parallel to the lines in the elevation, like for example, parallel to 1, 2, go there, parallel to 2, 3 from there, and you get it as well. I just want to show you that because it might be more applicable to some of the other points that we have. So then I join them up and just make sure they're nice and neat and clear. Apologies there, my pen keeps smudging. Nevertheless. Okay, so that's the elevation there. We'll apply a little bit of colour just so we can differentiate that set square. Okay, and so on. So there we go. That's that one right there. Now what we want to do is the 45 degree set square. So with the 45 degree set square, we only have 0.3 there at the moment. But what we can do there is we can bring up 0.8 now. So light projection line, bring 8 straight up. Okay, because it's in line with 3, we can actually bring the line straight across from 3. Okay, and what we've found then is our 0.8 right here. So once I have that, I can then heavy it like so. So I have the line 3.8, that's lovely. Now I want to find 0.7. Well, look, it's parallel to the side here. So in the case of this one, what we'll do is we'll go parallel, just to switch things up a little bit. Okay, so I'll go parallel to the line at the side, and I'll slide it back to 0.8, and I will connect it up to intersect this line going straight up, because 7 and 0.8 are in line. So that projection line going up to A also contains 0.7. So that's great. Okay, now what I want to do is join that back to 3. Okay, like so. And then I want to find the points inside, 11 and 10. Quickest way to do that, bring the line 4, 6 over, because they're all in line, aren't they? Okay, like so. Then we're going to project up 11. So this is all orthographic, lads, really. And so I'm going to mark the points. There's 11, and then there's 10, and then to find the 0.9, well, sure, look, we can use the same method if we want as we did for the other side. So why not? We can use our sliding set square, and of course you could go parallel again and all that. I want to reinforce this simple method of transferring points around. So there we go, like so. Bring it over, bring it up to the edge, like so, then bring it back in, like so, and bring 0.9 up to meet it. Of course I put the directional arrows on everything, went up there, went across there, this one went up, and then that gives us our 0.9. So we join 9 to 10, like so, 10 to 11, and 11 back to 9. Okay, now what we'll do is we'll colour that in. Now, lovely. So we can see there. Now what we need to do as well, don't forget, is heavy the outline. Okay, so probably about 2 marks going for heavy in the outline there. So remember to do that. Very easy to overlook that as you're going through the exam questions and so on. And like so. And we will just make sure that that's nice and neat. Okay, so the outline there done of the drawn board. Now, that's part A of the question. Part B. A line from point A is drawn on the surface of the board. The line has a true length of 50 millimeters and makes a true angle of 45 degrees with the bottom edge of the drawn board. given that this set square here is 45 degrees, alright, we can assume that the line it makes on the surface of the drawing board represents a 45 degree line. So what we're going to do is we're actually going to line up with that. So I'm going to take my set square and we're going to go in line with the line 7, 3. Okay, so I'm setting up like so, sliding the set square, slide it up to A. Okay, we'll use a different color here. So I'm actually going to bring a line out from A down to hit the bottom line of the drawing board. So technically speaking, because that line is parallel to that line, it represents a 45 degree, true 45 degree line on the surface of the plan view as we look at it. Obviously it's not actually 45 degrees because that is rotated slightly upwards, as you can see there in the elevation. But it gives us this point here. We'll call that point N. Okay? So we're going to take point N there now, and we're going to bring that up to a level line. We're going to rotate it. So I'm going to bring a line across from A, a level line, like so. Try and make that as clear as possible. I call it LL. Okay? Level line. And what I'm going to do is I'm going to get my compass here now. Okay? Put it on A. Stretch it down to N, like so, and I'm going to rotate it around to hit the level line. Okay, so you can see where it hits here. Okay, there's N there now. We're going to bring N out straight up to the XY line. There's N again. Okay, and we're going to join N back to A, like so. Now, when I join N back to A, what I can actually do on that line, because that actually now is the true length of, apologies there, my stuff is falling all over the place. That's the true length of the line AN as we see it. Okay? So what we can do there is we can mark a true length on it. So the 50 mil that was in the question, what we can do is we can mark that out there. So I'll use a bit of red for this. So I'm going to mark out 50 millimeters. Okay? It just gets me a point around here. That's the 50 mil. So that's the TL. Okay, and then this is the 50 millimeters. I'll put in a set of little arrows there to show you 50 mm. Okay. Now that's not the final position yet. We actually have to find the constructions there now. So very, very quickly, what we can do is we can take that point. We call it point P. Oh no, we already have a P, do we? No, we don't. Okay. Now we're going to take point P. We're going to project it down to the level line here in the plan view. So here's P. And then we're going to rotate P back around to hit the original line, like so. Okay, so as opposed this arc travelled out, this one's travelling back in. Okay, now it hits here and that locates P for us in the plan view, and it actually gives us the line for P there, the bit that we would heavy in the plan view. So I can heavy in that section of the line there. So that's actually the line coming from P as it would appear if we're looking down in plan. And now what I can do is I can project point P there as I've found it straight up to meet a line coming across from P, straight across, and that gives me point P right here in its final position, and I can join that back to A. So that's actually my line for P in plan and elevation. And that is the second question completed. Okay, so moving on again, we're going to look at the question up on the top here. It says A3, it says the image below shows the parabolic bridge at the M50 interchange in Dublin. The drawing shows the directrix DD1, the focus F, and 2 points P and Q on a similar parabola. Draw and locate the vertex and draw a portion of the parabolic curve which shall pass through P and Q. And then finally B, construct a normal to the curve at the point P. So straight away you want to recognize parabola. Okay, so parabola, that means if we're doing the eccentricity method, we're going to have a curve with an eccentricity of 1:1. So first thing we do here, never mind anything else, is we're going to draw our axis line. So through point F, okay, which is given to us, alright, we're going to draw an axis line. So you know that's a long dash short dash line, okay? And because it's a parabola, from where that axis line intersects the directrix there, we draw a 45-degree line, okay? Lovely. That's our line of eccentricity. If we remember what that is, LOE, line of eccentricity. Now what I want to do is from point F, I want to join back at 45 degrees to hit the line of eccentricity right there, and I want to bring a line back to hit the axis line right there. Now what does that give us? Well, it gives us our vertex V, okay? So that's the vertex there. So 45 degrees, straight back down, lovely. Now what I want to do is I want to draw in that very famous line called the latus rectum line, okay? So I'll take the latus rectum line. I'm just going to draw a line here straight through F. Don't worry about the length of it. Nice clear line there. Lovely. Now, what I'm going to do is I'm going to now put in my ordinate points. So between V and F, it's 15 mils. So I'm going to go 7.5 there, right? And what I'm going to do is I'm going to draw that line, or that point, straight up to hit the line of eccentricity, like so. I'm going to bring it to the latus rectum line. We'll call that the LR line, actually. Just put in LR. And then what we're going to do is we're going to swing that back. Now I may use... So what I'll do here is I'll position my compass on point F, and I'll stretch it out to the point, just locate it there, and swing it back to hit the original. Now it's ever so slight, okay? But that does give us a point on the curve, okay? So that's a point on the curve. Of course, point V is a point on the curve. And of course, the line, the latus rectum line from F, where it passes through the line of eccentricity, that's a point on the curve, okay? And essentially, that means the line of eccentricity would be a tangent to the curve, okay, which is true. So, next thing we want to do is mark out ordinate points down from F here. I think we'll keep them 10 mil apart, and we'll put 3 of them in, okay? We'll only be putting too much work on ourselves. We're only asked for a portion of the curve, so a portion will just work fine. So I'm going to mark using the green here, and I'm going to go like so, 10, 20, 30. Each of these points, okay, we can label them if we want. Go to the line of eccentricity like so, and then each of them points get brought back to hit the latus rectum, like so. And then what we can do then is we can, well, I'll put some directional arrows on there for you, just so you can follow what I'm doing. They travel like so. And then finally, get your compass now, put it on point F. Compass is always on F for these. And you're going to take the first one and swing back to hit the first line coming up. Second one, hit the second line coming up. And the third one, hit the third line coming up. So now I have those points located. Okay, and what I can do is I can transfer them over to the other side. I could have done it while I was doing that there, but I'm going to mirror them over, okay? So I'm going to mirror over. I'm just going to take some construction lines straight across. Don't worry about those lines, keep them nice and light. Okay, like so. And what we can do is we can take our standard compass here now, and for example, I'll go to the first one here, and I'll measure out to the point that I found on the curve, and I'll swing it around to intersect. I'll go to point F now. I'll measure out to the point there where it hits the line of eccentricity. Swing a curve the other side. Likewise for the next point. Swing. Next point. Swing. And then the next point. Swing. Okay? So then, once I have those points located, just mark the dots there. And like so. Of course, point P is matching up on it there. So that works out very, very well. Now what I'm going to do is draw the curve itself. So what we'll do is, nice and lightly, well, I'm actually using my marker here. But when you're drawing your curve, if you're not confident with drawing freehand curves, just draw lightly first. And then you can heavy in on your second pass around. And I'll bring that on out like so. Okay? So that's the parabola bit drawn. Okay, so that's part A dealt with. The next thing I want to do is I want to deal with the part B, which is construct a normal to the curve at the point P. So, what does that mean? Well, for example, here now what we're going to do is we're going to join a line. In the case of a parabola, join the line from F to P. Alright, I'll make it a kind of heavy enough line, like so. Okay? And then extend the line on that directrix line coming from the directrix through point P. Just extend that line on. Okay? Like so. So I have a nice heavy set of lines there. And what I'm going to do is I'm going to bisect the angle on those lines in just a moment. So what I'll do there is I will just get my compass and I will set any distance on the compass. At this point I can change the distance as long as I keep it the same for both of these arcs I'm going to draw here. Like so, bisecting the angle. Lovely. And I'm going to draw the bisector like so. Point P. That line there is the normal. So that is the job done. Okay? So there's nothing else we need to add to that. The final question then is the image below shows a fragrance bottle and diffuser reeds. So the given elevation and plan show two similar reeds represented by the skew lines AB and CD. A, determine the projections of the shortest horizontal line between the skew lines. So it's very important to note there straight away, shortest horizontal, because we have three types really: shortest distance at an angle, shortest distance, and shortest horizontal distance. So this is shortest horizontal, and it's going to have implications for what we're doing here further on. And then part B of that question is determine the true shape of the line AC. Determine the true length of the line joining A to C. Okay, so again, there's probably going to be a rotation in that to find the actual true length of that line. So let's get going at that there now. So in order to find the shortest horizontal distance, I firstly take a level line from B in the elevation, and then parallel to the line CD from the point A, I draw a line to intersect. That gives me my point 0. Essentially what I've created there is a triangular laminae ABO, and I'm interested in point O, so I drop it down to the plan view, again line up with CD in plan, go to A, parallel, and intersect the line coming down from O. That gives me O in the plan view. Now I want to join O to point B, and what that's going to give me, it's going to give me a true length of the level line, and that allows me then to extend on and create an auxiliary view. Okay, so the auxiliary view then, in this case, will be at a right angle to the true length of the level line. I'll highlight that in red, x1, y1. Apologies about the pixelation in the camera footage, having slight issues. Now I line up with the true length of the level line, and I'm going to take points A, B, C and D from the plan view out into the new auxiliary view. Of course this will be an auxiliary elevation, so I take the measurements from the elevation. So I take the measurement for A, and before I do so with these I just tend to drop construction lines down to the XY line so I can accurately mark out the points. Now C is on the XY line, so it'll be on the X1, Y1. The measurement for A is taken as such. The measurement for B, taken as such, marked out, and it's the same for D because B and D have the same height in the elevation. So those points there in the auxiliary view, their heights were obtained from the elevation. Now what I do is I connect C and D, and then I connect A and B, and both of those lines should be parallel. Okay? If the view is correct. Now for the shortest horizontal distance, our x2, y2 goes perpendicular to our x1, y1 line. Remember that. Okay? So now I'm going to extend on my projection lines out at the same angle as the x1, y1 line through the x2, y2. Now, when I'm taking my measurements here, I'm taking them from the x1, y1 line back into the plan view and stepping them out accordingly. So you can see me positioning on the x1, y1, measuring back to the individual points in the plan view, and then stepping them out. Okay, I label them then, as I always do. And what we're going to get here is we're going to get the two lines crossing over. Now the significance of the crossover point here is this is indicative of the shortest distance. Okay, so that point N is actually a point view of the shortest horizontal distance line, which is now going to be obtained in the auxiliary view when I project back. So you'll see me putting arrows on the line there, shortest horizontal distance. Okay, and that should be parallel to the XY line, as it is, the X and Y one. Now I take the points back, I label them 1 and 2, take them back into the plan view. 1 is on the line AB, 2 is on the line CD, and you can join those up. Okay, so that's the projections for the shortest horizontal distance in plan, and then into the elevation. And if everything is working out well, that should be a perfectly horizontal line in the elevation, 1, 2. And I'm just going to measure that shortest horizontal distance line there, that's 30 millimeters for me. And I'm just going to note SHD on each of the lines in the plan and elevation. Now the final part of the question there, we want to find the true length of a line joining A and C. So in the plan view what I'm going to do is I'm going to join the points A and C. So when I do that, I'm simply going to connect them up in the plan view and focus on the plan view. Okay, now like so. I could do it by auxiliary from here, but I don't want that. I'm going to use a rotation. Okay, so from A I'm going to draw a level line, LL. And from point A I'm going to rotate the point C around. So I get my compass, I'm going to rotate point C all the way around to hit that level line. Directional arrow, I'm going to project that now up to the elevation to the XY line. So extend the XY line out, your directional arrow is in. And then what I'm going to do is join that point back to point A. And once I have that done,